The first stars are thought to have ignited around 13 billion years ago in the early universe. Since then, over the eons, those stars have assembled into galaxies. And while we're just now detecting some of the light from the first stars, there are other, even brighter beacons of light that shine from the early days of the universe, quasars. In this episode, we'll look at these extremely bright objects powered by supermassive black holes. What are quasars? How do they form? And what can they teach us about our universe? If you've ever seen a jet engine up close, you know how powerful and awe-inspiring they are. Well, imagine one that shoots out 10,000 times more energy than our sun. That's a quasar. A quasar is the bright light we see coming from the accretion disk of a supermassive black hole. Supermassive black holes can have millions or even billions of times the mass of our sun packed into a region of space only a few dozen light-years across. As material falls into a supermassive black hole, it forms an accretion disk like the one you'd see around a much smaller stellar black hole. Material in the accretion disk gets heated to millions of degrees and emits huge amounts of radiation. The energy emitted from the accretion disk is what makes a quasar shine so brightly. The word quasar was coined in 1960 and stands for quasi-stellar radio source. They were the first objects that were discovered that were very distant and extremely bright. Today, astronomers think that quasars are the most luminous objects in the universe. Some are around 100 trillion times as bright as our galaxy. And when they first appeared in the universe, their luminosity was even greater. When looking at a quasar, you're seeing back in time. It takes light millions of years to travel from a quasar to Earth, so when we observe one, we're seeing it as it was millions of years ago. While the exact mechanism isn't fully understood, it's believed that quasars form when a supermassive black hole at the center of a galaxy pulls in surrounding gas and dust. This material is drawn in, it heats up and releases tremendous amounts of energy. Some of this energy is emitted as light, which we see as quasars. Some quasars emit huge jets of material that extend thousands of light-years away from the center of the galaxy, where the supermassive black hole resides. These jets are huge cones of material moving at near the speed of light. They consist of plasma or ionized gas particles. While the exact mechanism behind jets is still under investigation, it's believed that they are created when the charged particles in the accretion disk produce enormous magnetic fields. These magnetic fields are strong enough to draw material from the accretion disk along the black hole's rotational axis. Jets have been observed coming out of nearly every known quasar. And while we've seen them carry material away from a black hole, researchers believe that they also play a role in bringing new material in. Material ejected from a quasar through jets may eventually become part of a galaxy's halo. The structure of a quasar is complex, and not all quasars are the same. Broad line regions, NLRS, are found in many quasars. Their name comes from the broad emission lines seen in their spectra. Emission lines are a particular feature in the spectra of quasars and other astrophysical objects. When light from a distant object passes through gases, the photons can be absorbed by atoms in the gas. If the gas is cool enough, the electrons in the atoms will transition to higher energy levels. Then, the electrons will fall back down to their original energy levels and emit light. The wavelength of the emitted light corresponds to the energy difference between the two levels. This results in dark lines in the spectrum of light passing through that gas, called absorption lines. Conversely, if an object emits light, and that light passes through cooler gas, the electrons in the gas will absorb the light. This leaves dark lines in the spectrum of light emitted from the object. The emission lines we see from quasars come from the light emitted from the hot gas in the accretion disk. The inner part of the NLR is called the broad line region, or BLR. Here the gas moves fast, up to 10,000 kilometers per second. This high speed is why the spectral lines from the gas are broad. The outer part of the NLR is called the narrow line region, or NLR, because the gas there doesn't move as fast. Astronomers think the broad line region is relatively close to the supermassive black hole, whereas the narrow line region is further out. The narrow line region is thought to be part of a galactic structure called a torus. A torus is a donut-shaped cloud of gas and dust. Tori are thought to surround many galaxies, including our Milky Way. In fact, astronomers have good evidence that the material in the Tori is responsible for the obscuring clouds in our galaxy's center. Toria are usually opaque, blocking our view of the galaxy's nucleus. However, if a star or another bright object is behind a torus, the light from the background object can pass through the thinnest parts of the torus and reveal what lies in the galaxy's nucleus. Because quasars are so bright, their light can penetrate the obscuring torus and allow us to study the galaxy's nucleus. Around the supermassive black hole, at the center of a galaxy, there's a large amount of gas and dust called the circumnuclear disk. The material in the circumnuclear disk forms an accretion disk around the black hole. The material in the accretion disk is heated to millions of degrees and gives off huge amounts of radiation. The radiation emitted by the accretion disk is what powers the quasar. Quasars are among the brightest objects in the universe, and they emit radiation across the electromagnetic spectrum. But their radiation peaks in the ultraviolet and infrared, not the visible. So why do we see quasars as having a bright white light? The reason is that when the light from quasars passes through Earth's atmosphere, most of the ultraviolet and infrared light is absorbed. Only a small fraction of the light reaches the ground. However, this tiny amount of light is enough to make quasars visible to the human eye. We can also detect quasars emitting radio waves and X-rays. How long do quasars shine? For most quasars, we don't know exactly how long they shine. They might stay bright for millions of years before fading away. But for some of them, the shining period might last hundreds of millions of years. And the reason quasars fade is probably that they run out of nearby material to feed on. Without new material falling into the supermassive black hole, the accretion disk can't form and the quasar can no longer shine brightly. There are different ways to classify quasars. One way is to classify them based on their luminosity. Another is to classify them based on their emission lines. Astronomers have identified several types of quasars based on their emission lines. Each type has a different spectrum of emission lines, which suggests that each type of quasar has a different structure. One of the most common types of quasars is the Type II quasar. Type II quasars don't have broad emission lines in their spectra. Instead, they have only narrow emission lines. The lack of broad lines suggests that the gas in the broad line region is not present in Type II quasars. What can quasars teach us about the early universe? As mentioned earlier, quasars are incredibly bright. This means that we can see them as they were in the past, as the light from the quasars took millions of years to reach us. By studying quasars, we can learn about the early universe. For example, by looking at the spectra of quasars, we can identify the elements present in the gas in the broad line region. This is important because it gives us a snapshot of the chemical activity in the early universe. Also, the light from quasars can be used to measure the rate at which the universe is expanding. By measuring the redshift of the light from quasars, astronomers can determine how fast the universe is expanding. This is important because the rate of expansion of the universe is accelerating, and scientists would like to understand why. As we look deeper into space, we're looking back in time. As the light from quasars took millions of years to reach us, studying them allows us to see back to the early universe. Quasars are among the most luminous objects in the universe. Some are around 100 trillion times as bright as our galaxy. This brightness makes them easy to spot from Earth. And because quasars are so bright, they can help us probe the nature of the universe. While we've come a long way in understanding quasars, there's still much we don't know about them. In the future, all of the information we gather about quasars should give us a better understanding of the early universe. Thank you for watching this episode. If you liked it, please subscribe to the channel.